Okay, so we're starting chapter 5.1, which is a chapter on radical expressions. And I first wanted to explain what a radical is. A radical is divided up into a few parts. We have the index or the root, which is n, designated by n, the radical sign, and the power. M is designated as the power. So examples of radicals could be the square root of 23. Notice if there's a square root, we don't normally write in the 2 because no number for n here means that it's a square root. Or you might have something like the cube root of x squared or the fifth root of negative 125 and so on. Now, the way this works is that one simple rule n, the nth root of a is equal to b means that b to the power n is equal to a. In other words, the square root of 36 is equal to 6 means that 6 squared is equal to 36. Or the third root of 64 is 4 comes from the fact that the 4 to the third power is equal to 64. The fourth root of 16 is equal to 2 comes from 2 to the fourth power is equal to 16. Now we can consider a couple of things here. If we've got the third root of say negative 64, this is equal to negative 4 because negative 4, sorry, this is, let's write that back. The third root of negative 64 is equal to negative 4 because negative 4 to the third power is equal to negative 64, right? It's negative 4 times negative 4 times negative 4. Or the third root of negative 125 is equal to negative 5, comes from negative 5 to the power 3 is equal to negative 125. So if the root is an odd number, then the number underneath the root sign would have a negative value. Let's look at a case here of negative third root of negative 27. Now we know that the third root of negative 27 is equal to negative 3. Okay, since negative 3 to the third power is equal to negative 27, So this is equal to the negative of negative 3, which is equal to positive 3. If we have one step further, if we have the square root of 1 over 9, this is the square root of 1 over the square root of 9. The square root of 1 is 1, so this is 1 over 3. Or if we've got the cube root of 8 over 27, this is the same as writing the cube root of 8 over the cube root of 27, which is 2 over 3. The square root of 81 is equal to 9. The square root of negative 81 is not a real number. Okay? Because there's no number that can be squared to give negative 81. See the difference? But if we had the cube root of negative 27, that's equal to negative 3, since negative 3 to the third power is equal to negative 27. FYI, a lot of these could be simply checked with the calculator so long as it's a perfect square. For example, I could find the square root of, say, 49 is equal to 7. I could find the cube root by pressing second and math, and let's clear that. Second math. I don't know what's happening there. Something's not coming out clearly here. Oh, I'm sorry. It's just press the map button and select number 4. And we can take the square root of negative 125 and get negative 5. I'm sorry, the cube root of negative 125 and get 5. Or we can take the cube root of negative 27 and get negative 3. But look what happens if we try to take the square root of a negative number, say negative 36, we get what's called a complex number. Now, this 6i means that the number is not a real number. Okay, not a real answer. Okay, all right, let's go back to what we were doing here. So if we're trying to determine, say, the square root of 24, we would have to split this up into the highest possible square in here, which is 2 squared times 6. And then this is the square root of 4 times the square root of 6, which is 2 square root 6. Or if we're trying to find the square root of 50, this is the square root of 25 times 2, which is the square root of 25 times the square root of 2, or 5 square root 2. 1 square root of 10. Since 10 is 2 times 5, this cannot be simplified. if we wanted to find the square root of 108, this is the square root of 36 times 3, which is the square root of 36 times the square root of 3, which is 6 square root 3. So now we have to consider a couple of things here. If we're writing n of a to some power m, this may be written as a n over m, where the power is on the top and the root is on the bottom. So this would work, for example, if we have, say, the third root of x to the power 4. This can be written as x 4 over 3. All right, now the process for simplifying radicals when we have a variable underneath it. Let's consider, this is a little different from what it's taught in the textbook. If I have x to the power 5, and we know this is a square root, so this is the square root of x to the power 5. The way you would do this is you would divide 5 by 2, write this, and write this. Divide 5 by 2, you get 2 plus 1 remainder. So all you do here is put this is 2, and then this is to the power 1. Or if I have, say, x to the power 17, you would write x divide 17 by 2, get 8 plus 1 remainder. So x to the power 8 and the 1 remainder in here. If I have y to the power 21, this is square root of y to the power 21. 21 divided by 2 is 10 plus 1 remainder. So x to the power 10, that is y to the power 10 plus 1 remaining y. If I have the third root of x to the power 19, this is x, third root x, 19 divided by 3, 6s are 18 plus 1 remainder. So x to the 6th power and 1 remaining underneath. If I have the 5th root of x to the power 27, this is x, 5th root, 27 divided by 5 is 5 plus 2 remainder. So x to the power 5 and the 2 remainder goes on the power underneath the square root sign. Also, don't forget to consider the simplest of cases. If I have the square root of x to the power 6, simply divide 2 into 6 and that would give you x cubed. So let's consider a couple of cases here. I've got -8. These are examples from the homework. -8, the 5th power of 64, x to the power 19, so we need to simplify this. This is -8 and then we know that 64 is 2 to the power. Think about 64, 2 times 2, 2 2's 4, 4 2's 8, 8 2 16, 16 2 is 32, 32 times 2 is 64. So this is 2 to the power 6. So we can write this as -8, the 5th power of 2 to the power 6, x to the power 19. -8, the 5th root of 2 to the power 6 is 5 into 6 is 1 time and 1 remaining. So this is, we bring the 2 outside, it goes 1 time, and then there's 2 to the 1 power remaining. Then 5 into 19, 5 3's 15, and 3 remaining. I'm sorry, 4 remaining. 4 remaining. So this is x to the power 3 and 4 remaining. So this is -16 x cubed, the 5th root of 2x to the 4th power. Fourth. From the homework, square root of m to the power 9. So write 1m, another m here, and then here 9 divided by the square root 2 is 4 plus 1 remainder. So this is m to the 4th power and the 1 remainder. We would just write as m4 square root m. Square root of 81 x to the power 9. The square root of 81 is 9. We put an x. Put an x here. 9 divided by 2 is 4 plus 1 remainder. So 4, and then the 1 remainder. X to the power 1 remainder in here. Square root of 20x to the 6th power y to the 11th power. So we have to do a little work here. This is the square root of 4 times 5, x to the 6th power, y to the 11th power. The square root of 4 is 2. Put an x, put a y. We have 5 remaining under here. We have x, we have y. Then 2, 6 divided by 2 is 3. Nothing remaining, so we take out the x. And then 11 divided by 2 is 5 plus 1 remaining. So 5 and 1 remaining here. So we kind of close this up nicely and say this is 2x cubed y to the power 5 square root of 5y. Negative 3, 125x squared. So negative 3 square root of 25 times 5 x squared. Negative 3, the square root of 25 is 5. We put an x here, we put a square root, and we have a 5 remaining under here. Then 2 divided by 2, the power of x. Okay, 2 divided by 2 is 1, and nothing else remaining underneath the square root sign. Nothing else remaining underneath the square root sign. So this is negative 15x square root 5. Similar problem, negative 3, the cube root of 125x squared. So the cube root of 125 is 5. And then 3 cannot divide exactly into 2, so we leave the x squared underneath, okay? Underneath the radical sign. 8, the fourth root of 81x to the power 11. So the fourth root of 81 is equal to 3, since 3 to the power 4 is equal to 81. So this is 8 times 3. 4 goes into 11 2 times, and 4 2's 8, and 3 remaining as the power. Okay, that's 11 divided by 4, which is equal to 2 plus 3 remainder. One last example. got the third root of negative 27, a to the power 6, b to the power 12, c to the power 16. So we're going to do this one really quickly. The cube root of negative 27 is negative 3. Then 3 divides into 6 exactly 2 times. 3 divides into 12 exactly 4 times. And 3 divides into 16 5 times, and 1 c remains. This is a cube root c. This is actually question 12 on the homework. And it's, before I do this, let me speak a little bit about the Pythagorean theorem. The Pythagorean theorem says if we have a right triangle the side opposite the right angle is called the hypotenuse, and it's usually designated as C. The short leg is A and the long leg is B. And the Pythagorean theorem says C squared is equal to A squared plus B squared. So question 12 says somebody has a ladder and they show a picture of a ladder leaning on the sides of a house, and they said that the ladder is placed 10 feet from the side of the house, and they're trying to get to 31 feet, and they want to know what length of ladder. So we would use the Pythagorean theorem here. Here C is the hypotenuse, so the ladder length is C. A is the short side and B is the long side. So C squared is equal to A squared plus B squared. So C squared is equal to 10 squared plus 31 squared. So C squared is equal to 100 plus 31 squared from my calculator gives 961. So C squared is equal to 1061. So C is equal to the square root of 1061. This is how you would have to type the answer into my to iMathAS. Now, as a real number, this is approximately equal to 33 feet if we were to put it into the calculator. Okay, but you need to, when you type in the answer, type in square root and whatever number you have on the bottom in order to get the problem correct. And next we're going to look at using the calculator. Using the calculator to find square roots. So the square root of 87, you would go to your calculator, press second and the x squared button. I tell you what, let me put in the key press history so you can see what buttons I'm pressing. Okay, so second, oh, I need to clear this first. Okay, let's start over. So second, and it shows you on the bottom what buttons I'm pressing. So second and the square root button, the x squared button, and type in our number 87, and we see that it's approximately 9.32. So this is approximately 9.33. I'm going to capture that screen, and if you're rounding it to 2 decimal places, which I believe is what the homework is going to ask you to do, you would enter it as 9.33. Okay, if we have this square root of negative square root of 121, so I would go to my calculator, press the negative sign, second x squared, 121, enter, and I can see that that is negative 11. Let's go ahead and place that in here. I'm going to place it down here. It's a little easier to get. So this is equal to negative 11. All right, just a couple more answers, a couple more problems. If you're asked to evaluate f of x is equal to 2x plus 5. So I would and the first one we're asked to evaluate is 0, so you would simply substitute 0. 2 times 0 plus 5, which is 0 plus 5, which is the square root of 5. Or you may be asked to evaluate negative 1. So 2 times negative 1 plus 5, which is negative 2 plus 5, which is square root of 3. Or you may be asked to evaluate 5, which is 2 times 5 plus 5, which is 10 plus 5, which is equal to square root of 15. Square root of 15 cannot be simplified further. One last example. F of x equals to the cube root of x minus 23. And if we're asked to find f5, so this is the cube root of 5 minus 23, which is the cube root of 18, negative 18. And since we know that we can take the cube root of a negative number, we put the negative sign outside and say this is 18 like that. F negative 2, cube root of negative 2 minus 23, which is the cube root of negative 25, or negative cube root of 25. And F26, the cube root of 26 minus 23 is equal to the cube root of 3, which cannot be simplified. So we're pretty much stuck with that as the answer. All right, that's all I have for you guys for chapter 5.1. We will continue with chapter 5.2 shortly.